Okay, so last class, we went over factoring. Some of you may have been a review, others if you didn't learn it the first time, hopefully it made sense this time. So today we're going to go over special cases of factoring. Okay, so first, we're going to go over perfect squares. Okay. And you have two formulas for perfect squares. You have a squared plus 2ab plus b squared equals a plus b squared. And you have a squared minus 2ab plus b squared, which is a minus b squared. Okay. And you can prove either one. So if you wanted to prove the second one, a minus b squared is just a minus b times a minus b. And do the FOIL method. You have your first, which is a squared. Your outer is negative ab, and your inner is negative ab. You add those two together. Negative 2ab plus your last, negative and negative is positive, positive b squared. Okay, so let's say for example, if you wanted to factor say x squared plus 10x plus 25. Okay, so the first thing you would notice is that the first and the last term are perfect squares. So here you have x squared. We'll leave the middle blank for now. And on the outside you have 5 squared. Since 5 and 5 is 25. Okay. So since the first term is a perfect square, and the last term is a perfect square, for this one, I'll put in a little box here. So because both of these are plus, you're looking to see if it fits a squared plus 2ab plus b squared equals a plus b squared. Okay, and you do that by once you're figuring out this, you look at this middle term. Here, in order for this to match, your a would have to equal x. In order for this one to match your 5 squared, that means your b would have to be 5. That means for this to be a perfect square, this middle term would have to be 2 times a times b. And it would have to match this. Okay? So if you have 2 times a, which in this case is x, move it up a little bit, times b, which in this case is 5, clearing that up a little. Okay, so you have 2 times 5, which is 10, times x, so you have 10x, which matches up here. Okay, so this is a perfect square, or a perfect square trinomial. Okay, so because it fits this formula here, you can actually just solve it by making your a plus b and then squaring it. So this is just x plus 5 squared. Okay, so that would be your perfect square trinomial. So all you did was just get this formula and factor it to become that one. Any questions on that one? Now, of course, you could have also used, oh, thank you, bring it up some, x squared plus 10x plus 25. Since there's nothing in front of the x squared, you could have had two numbers that multiply to equal your c, and those same two numbers add to equal your b. Okay. In this case, 5 and 5 would work for both of them. Okay. Which means this would factor into x plus 5 times x plus 5. Uh-oh. Run out of room there. There we go. Which is just x plus 5 squared. Okay, but that's if there's nothing in front of the x squared. Sometimes when there is a coefficient in front of the x squared and it's so big that doing the a times c method, where you have to do a times c, have to find a number that multiplies to give you the a times c and adds to give you b, then you replace the b and all those other steps, it's a lot easier to do it this way in some cases. All right, so let's do another example. Oh, I'm still writing. All right. Okay, so let's say if we have to factor 4x squared plus 4x plus 1. All right. Now in this case, we could use the a times b method, but again, that's a little bit lengthy. Whenever you can avoid it, it's best to avoid it. So we notice here that 4x squared, you can actually rewrite that as 2x squared. Okay, because 2x times 2x, just multiply the 2's and multiply the x's, and you have 4x squared. And 1 is you can write that as 1 squared. Okay, so we know the first and the last term are perfect squares. Okay, so we know just from that our 4x squared plus 4x plus 1 can be rewritten as 2x squared. Leave that middle one blank for now, plus 1 squared. You can use the parentheses if you want to, you don't have to. Okay, and we're trying to match it up. Remember, since that's plus, we want to match it up with a squared plus 2ab plus b squared equals a plus b squared. Okay, so in order for this to match up, that means this would have to be our a. So our a would have to equal 2x. And our b would have to equal 1. Okay, so that means this middle term here would have to match this one. So that means 2 times a times b would have to give us 4x for that to be a perfect square. Does that make sense? All right. Okay, so we can go ahead and test that out. So you have 2 times a, which is 2x, times 1. Okay, so you have 2 times 2 is 4 times x, so you have 4x times 1, which is 4x. So it matches. Okay, so you know this is a perfect square. So it matches the middle term. Okay, so now that we know it matches, that means all we have to do, instead of doing all the factoring and everything else, we just plug it into a plus b squared. Okay, so that gives us a plus b squared is just our a, which is 2x, plus b, which is plus 1, squared. And that's our answer. All right, any questions on that one? Okay, so let's do one that's a little bit bigger. I'll leave that up for a second. All right. Uh-oh. So let's try example here. So let's say we wanted to factor 64x squared minus 32x plus 4. Okay. So now if you want to do the A times C method, it'd be 64 times 4, which would give you some big number. I think it's 128 times 2, which is more than I feel like doing in my head right now, but you kind of get the idea. It's a big number to try and mess with, especially when you don't have a calculator on the exam. Okay, so this is where this method really comes in handy, because you don't have to deal with those big numbers. Okay, so the first thing you want to notice is that 64x squared, 64 is just 8 times 8. And x squared is just x times x, so you can just make that into 8x squared. Okay, and 4 is just 2 times 2, or you can just make that 2 squared. Okay, so once again, we see that our first and last terms are perfect squares. Okay, so once we see those first and last terms are perfect squares, now we start to plug them in and see if it fits the formula. Okay, so we have our 64x squared minus 32x plus 4. We can just rewrite that. Instead of 64x squared, make that 8x squared. Leave that middle term alone for now, because we still have to kind of experiment with that one. And you have plus 4. Okay. Now the sign in front of that middle term is negative. So instead of the a squared plus 2ab plus b squared, we're going to use the minus 2ab, because that's how it will match up. Okay, a squared minus 2ab plus b squared equals a minus b squared. Okay, so that sign alone will let you know which formula you're going to use. Okay, so we know this still has to equal 2 times a times b. Okay, and we know just from here that our a is equal to 8x. Oh, forgot to make that 2 squared. Sorry about that. And that becomes 2 squared, so that means our b is equal to 2. So if we can get this middle term after multiplying 2 times a times b to match 32x, then we know it's a perfect square. Okay, so we have 2 times a, which is 8x, times b, which is 2. Okay, 2 times 8 is 16. 16 times x is 16x. 16 times 2 is 32, so it matches. Okay, so it's 32x. Okay, so we know it's a perfect square. Or a perfect square trinomial. That's the whole name. So it is a perfect square trinomial. So all we have to do is just plug this into that formula. Okay, so we know that a minus b squared is just 8x minus 2. And that whole thing is squared. Okay. You can always double check your answer by just move that up a little bit. Eight x minus 2 squared is 8x minus 2 times 8x minus 2. And you just do the FOIL method. Okay, so your first 8x times 8x is 64x squared. Your outer is 8x times negative 2, which is negative 16x. Your inner is 2 times 8x, which is negative 16x. And your last is negative 2 times negative 2, which is positive 4. Combine those like terms, and you end up with 64x squared minus 32x plus 4, which is where you started. All right. So any questions on that one? All right. Leave that up for a second so you can finish writing that. All right. One more example. Okay, so let's say if we wanted to factor 49x squared minus 126x plus 81. Okay, so I'll let you start on this one. Remember, the first thing you want to do is look at the first and last numbers. right, so let's start on this one. Okay, so the first thing you should have noticed is that 49x squared, 49 is just 7 times 7. So that can just become 7x squared. And 81 is just 9 times 9, or 9 squared. So again, our first and last terms are perfect squares. Okay, so we just go ahead and rewrite it. So 49x squared minus 126x plus 81 will just become 7x squared. Again, we're going to temporarily ignore that middle one, plus 9 squared. Okay. So that minus sign let us know that we're going to use the a squared minus 2ab formula. Plus b squared, which is a minus b squared. Okay, so that means this middle term has to equal 2 times a times b if your a is 7x, and if your b is equal to 9. Okay, so we go ahead and test it out. So you have 2 times a, which is 7x, times b, which is 9. Okay, and we'll go ahead and do that on the side there. 2 times 7x times 9. 9 times 7 is 63. So you have 63 times 2 should be 126. 2 times 3 is 6. 2 times 6 is 12. 126. So you have 126x. Which is exactly what we were looking for. Okay, so once you get there, all you have to do now is realize that this is a perfect square. Make sure I'm up high enough. Well, perfect square trinomial. Okay, so your a minus b squared will just become 7x minus 9 squared. Okay. Now, if you did happen to do the check your outside and you do your 2ab and it doesn't match your middle term, then you'd have to do the a times c method. Okay. So it won't always be a perfect square, but when it does match, it cuts down a lot of the work, because that a times b method, you'll be doing 49 times 81 and have to find two numbers that multiply to equal that and add to equal 126, and it's just a mess. So this is a little bit easier. All right. Any questions on this one? All right. Okay, so we'll move on to the next one. We're actually going to come back to problems that will use perfect square trinomials, but for now, we're just going to move on. Okay, and the next will be difference of squares. Okay, and we know difference is just a fancy way to say subtract. So if you subtract squares, that means you have one square minus another square. Okay, so the formula for that is a squared minus b squared equals a plus b times a minus b. Okay. And once again, if you wanted to check that out and make sure it's true, you just do the FOIL method on this one. A plus b times a minus b is just, using the FOIL method, a times a is a squared. Your outer is a negative a times b. Your inner is positive a times b. And your last is negative b squared. Now in this case, minus ab and plus ab cancel out to equal 0. So you end up with a squared minus b squared. Okay, so let's do a quick example of this one. What if we wanted to factor x squared minus 9? Okay, so just like before, when you had the first and last term, first thing you would notice is that they were perfect squares. You do the same thing here. But it's only 2 terms, so you just notice both terms are perfect squares. Okay, so x squared is just, of course, x times x. Or you can rewrite it in parentheses. You don't have to. And 9 is just 3 squared. Okay. So that means our x squared minus 9 can be rewritten as x squared minus 3 squared. Hence the name difference of squares. Okay, so in this case, your a is equal to x. And let me put the parentheses. Sometimes the parentheses help. And your b is equal to 3. Okay, so you just plug it right into the formula. So a plus b, a minus b, a squared minus b squared. Okay, so that means that will equal, your a is equal to x, so you have x plus 3 and x minus 3. And again, to check it, you just do the FOIL method and see if it comes out to be correct. All right. So any questions on this one?